Lesson 4.2 is coming from a different packet than our standard notes. It says Reflection Rules Part 1. Typically, this first page we would do in class like with a partner or some sort of like self-discovery. We're going to start on Reflection Rules Part 2, and I'm going to show you how this works. So we're going to be reflecting images and reflecting points. And you guys kind of know what reflections are because you probably look at your reflection in the mirror many times a day. Most bathrooms usually have mirrors in them in the US. So you're familiar. If you don't know much about your reflection yet, go to the mirror and hold up your right hand. And when you hold up your right hand, the person in the mirror is holding up their left hand. So sometimes in reflections, things get flipped around a little bit, but most of the time when you look at your reflection in the mirror, you still look like you. You still have, your eyes and your nose and your mouth are still in the same place. And if it's a standard mirror, they're also the same size. So keep that in mind also. What we're going to do is we're going to take and we're going to reflect some triangles. And the reason we're doing this is because there are rules to reflections. And if you know the rules, it's actually a pretty quick thing to do. It's a fast thing. But memorizing the rules tends to be very, very difficult. It's not something that you're going to remember 2 or 3 weeks from now, let alone 6 months from now or a year from now. So we're going to practice how to figure out these rules without straight memorizing. So the first thing we're going to do, we're going to take this little triangle there. Looks maybe like this one. And we're going to reflect across the x-axis. The x-axis is this one. Now reflect, another word for reflect is to essentially flip. So we are taking this triangle and we are flipping it down, flip it down across the x-axis. And it would look something like that. So the triangle, when flipped, looks something like this. And the point 3,1 that was at the top of this triangle here is now at the bottom. It changes into the point 3, -1. So what happened to the numbers? What happened to the x and y values? Well, the x value stayed the same. The y value changed sign. It changed from positive to negative. When you flip across the x-axis, nothing happens to the x, but the y changes sign. Reflecting across the y-axis. All right, here's our triangle again. Here's the y-axis, and we're going to take that triangle and we're going to flip it over. So take it, flip it over that center y-axis. And when you do that, take your triangle, turn it over, and it ends up right about here. Instead of going right and up, it goes left and up and looks like this. So the point 3,1 actually turns into the point -3,1. So what happened to those numbers? The x changed sign. The y, nothing happened to it. All right, the next one. The x and the y axes tend to be fairly easy ones to see. The next two are a little trickier. We're going to reflect across the line y equals x. The line y equals x is this line right here. Slope of 1 goes to the origin. And when we flip this, the side that is on the x-axis needs to end up on an axis. So flip that triangle, turn it over. So if it's going this way, flip it up this way, and it goes onto the axis, the y-axis. It's going to look like this. See, the triangle flipped over. So instead of like the point being kind of up, it's now to the right. So the point 3, 1 turns into the point 1, 3. So what happened here? 3, 1 turned into 1, 3. They switched order. The x and your y just switch places. That's all you have to do for that one. And then the last one, reflect across y equals negative x. Reflecting across y equals negative x tends to be another line that you maybe don't know. Instead of a positive slope of 1, it is a negative slope of 1. Goes more like this. And again, reflect means to flip. So here's a bigger triangle. It's easier to manipulate. Take the triangle and flip it down and over the line. So instead of going right, flip it and it goes down. See the flip? The flip up here takes it and flips it up. Takes the triangle and flips it up. This one takes the triangle and flips it down. So that your triangle, when it's done, goes down and left. Looks like this. Remember, the side that was on the x-axis needs to stay on an axis. So the point 3, 1 turns into the point negative 1, negative 3. So here, they switch order. The 3 turns negative, so the x changed sign, and the y changed sign. Now, if you're having trouble picturing these, a lot of times I use my hand as my triangle. This is about a 3-to-1 ratio, so it works well for 3, 1. Flipping along the x-axis means you flip your triangle down. 3, negative 1. Flipping along the y-axis means you flip your triangle this way. Negative 3, 1. Positive 1. To flip along this diagonal means to take your hand, and it kind of almost hurts, but to flip it up and over. So you take it and you flip it up and over. To flip it down, you take it and you flip it down. It tells you which direction the final triangle should go. Take a moment, practice those, because those movements of turning this picture is key for remembering these rules. We're flipping back later into the packet to the page that says let's apply the patterns together. Let's do a couple of these together. So the first one, graph triangle JKL and its image after a reflection in the given line. So we're going to start by graphing JKL. J is negative 4, 7. K is 5, 8. Means right 5, up 8. L is negative 1, negative 6. And it's a is it a triangle? Yeah, triangle JKL. So you're going to connect that triangle. Now, to actually show your work, first thing we're going to do is we're going to write our 3 points. We're going to make a chart just like we did in section 4.1. JKL turn into J prime, K prime, L prime. Now all we need to do is figure out the rule. So in section 4.1 we wrote like x plus 3 and y minus 2. Here though, we don't have the formula. We don't have a set rule. So we have to think. In the x-axis. The x-axis is left and right. If we took our triangle and we flipped it over the x-axis, what happened to this point 3, 1? Or what happened to this point? It didn't move left or right at all, but it did go from above to below. The point 3, 1, when flipped, turns into 3, negative 1. So 3, 1 turned into 3, negative 1. What changed? What happened? We changed the y. And that's all we did. The second number, and I like to circle them so I don't get confused. The second number changes and nothing else happens. So negative 4, 7 turns into negative 4, negative 7. 5, 8 turns into 5, negative 8. Negative 1, negative 6 turns into negative 1, positive 6. And we graph those. Negative 4, negative 7 is J prime. 5, negative 8 is K prime. Negative 1, positive 6, L prime. And we have our next triangle. All right, let's look at the next one. JKL across y equals negative x. So let's start by plotting JK and L. J is 0, 7. K is negative 4, negative 5. L is 3, 2. And we write the points down. J, 0, 7. K is negative 4, negative 5. L is 3, 2. And they turn into J prime, K prime, L prime. All we need to do is figure out the rule and then do it. So, y equals negative x. That was the line that kind of goes down, which means we took our triangle and we flipped it down. So the point 3, 1 turned into the point negative 1, negative 3. What happens? We switch the order. And we actually changed both the x and the y. So I'm going to write change both. We switch and we change both. So, getting a little squished here, I'm going to rewrite that here. Switch and change both. So 0, 7, switch the order and change both signs. It turns into negative 7, 0. Negative 4, negative 5, switch the order and change both signs. 5, 4. 3, 2, switch the order and change both signs. -2, 3. Those are what we need to plot. J prime is -7, 0. K prime is 5, 4. And L prime is -2, 3. Now something seems weird to me. Look at the first triangle and look at the second triangle. The purple triangle, to me, the first one, looks bigger or wider or something. And this J prime, K prime, L prime looks almost too skinny. They don't look the same. You see, these two triangles back here, they look the same. They look the same size. These don't to me. And if they don't look the same size, then that means that something went wrong, because both triangles should look exactly the same. And that's why we show the work. So what went wrong? Either these points, maybe there's something wrong here, or I just graphed them wrong. So let's see. If you look carefully, my mistake's right here with L prime. I switched the order, but I didn't change both. It should be -2, -3. In which case, L prime is here, and the triangle looks like this one here. And that looks better to me. Those look the same size. If the triangle looks like a different shape, something went wrong. Go back and look for your mistake and find it. They should be the same shape. Now for example 3, reflect the image over the line y equals x. So here it's kind of the same thing as up here. The only difference is that in example 1 and 2 I gave you J, K, and L. Here I don't actually give you A, B, C, D in the exact same way. What I do give you is a picture. And you have to find your own A, B, C, D from the picture. So A is left 3 up 2. It's -3, 2. B is right 1 down 1. So 1, -1. C is left 2 down 2. So -2, -2. And D is left 4 down 1, -4, -1. And they will turn into A prime, B prime, C prime, D prime. All we need to do is figure out the rule. So reflect over the line y equals x. That's the one tilting up. So you take your triangle and you're going to flip it up and over. Little hard to do. Under a camera perhaps. Take the triangle, flip it up and over. So instead of going right 3 up 1, look at where the 3 and the 1 are now. So now the point 3, 1 turns into the point 1, 3. So what do? What happened? 3, 1 turned into 1, 3. So we just switched the order. That's all we need to do. -3, 2, switch the order. 2, -3. 1, -1, switch the order. -1, 1. -2, -2, switch the order. -2, -2. -4, -1, switch the order. -1, -4. Graph those points. 2, -3 is your A prime. B prime is -1, 1. C prime doesn't actually change, and D prime is -1, -4. And you have your new shape. Last one, we're going to do a composition. Graph triangle RST with those vertices RS and T, and its image after the glide reflection. Now, a glide reflection is a fancy way of saying a translation and then a reflection. Remember, translate means to slide. Glide is just another word for slide. So, let's start by plotting our points. R is -3, 5. S is -5, 0. And T is 6, 1. RST. So we're going to make our chart just like before. R is -3, 5. S is -5, 0. T, 6, 1. RST will turn into R prime, S prime, T prime. Now, of the translation and the reflection, how do you know which one to do first? Well, you do the first one first and the second one second. Don't do the second one first because it is listed second. Do it second. So we're going to do the translation first, and that's the rule x plus 2 and y minus 3. So we're going to write x plus 2 and y minus 3, and we're actually going to do that. And we're going to write it down, -3 plus 2, 5, minus 3. X plus 2, y minus 3. -5 plus 2, 0 minus 3. X plus 2, y minus 3. 6 plus 2, 1 minus 3. And our points, R prime, S prime, and T prime, are actually whatever we get here. So -3 plus 2 is -1. 5 minus 3 is 2. -5 plus 2 is -3. 0 minus 3 is -3. 6 plus 2 is 8. 1 minus 3 is -2. That is R prime, S prime, T prime. But then, there's more. Now we need to reflect, which means we're going to get R double prime, S double prime, T double prime. We need the rule for reflecting across the across the y axis. So the y is the one that's going up and down. We're going to take our triangle and we're going to flip it across the y axis. So the point 3, 1 turns into the point -3, 1. 3, 1 turns into -3, 1. What happens? What changed? Or what stayed the same for that matter? So the order stays the same. The x value changed. So you change the x sign. That's all we're going to do. Take your R prime, S prime, T prime, and change the x sign only. Now, I find it helpful to go through and just circle the x values. That way I don't get confused in the middle and just switch for whatever reason. So change the -1, keep the 2 the same. Change the -3 to +3, keep the second one the same. Change the 8 to a -8, keep the -2 the same. And there we go. There's R double prime, S double prime, T double prime. All we have to do is graph it now. So, the point 1, 2 is R double prime. S double prime is 3, negative 3. T double prime is negative 8, negative 2. And we've got our second triangle. I always verify, do they pretty much look the same shape, same size? They do. Maybe one's been flipped or turned, that's okay. It can be slid over, that's okay. But as long as they're generally the same shape and size, you've probably done it correctly. You should now have enough information to go ahead and do your homework.